Hello everyone, I hope all of you are fine. Today our topic is what is electric charge, what is quantization of charge, and how charge is conserved. But if you know more about charge and what is inside of charge and similarly what is Coulomb law, then for that you must have to subscribe my channel because our next topic is a Coulomb law, which is also related to the charged particles. Now let's come towards our topic, what is charge? In 1600, Greeks experimentally verified that when amber is rubbed with a silk, it attracts small pieces of straw. Similarly, if you rub a glass with a silk, then it attracts small pieces of paper, or if you rub a plastic rod with fur or with a woolen cloth, then it also attracts small pieces of paper. In Benjamin Franklin's day, in around about 1600, for the first time, Franklin assigned positive and negative labels to the charged particles. And he performed his famous kite experiment and experimentally verified that basically the lightning occur during the thunderstorm or in the clouds possesses charge. Now let's come towards our topic, what is basically charge, how we can define charge. So charge is basically the property arises due to the deficiency or excess of electrons, or we can also say that the source of electricity is called charge. When one body attains positive charge and other negative charge, then it means that basically something transfer, which we later called charge, basically transfer from one body to another body. When one body possesses positive charge, it means that that body lost electrons, and when other body gain electron, then that body attain negative charge. And the example of that is for example, sodium. When sodium lost electron, it attained positive charge, and when chlorine gain electron as a result of the loss of the sodium, then chlorine attain negative charge. So due to the loss or gain, the deficiency or excess of electron in these two particles, or we can say that atoms occurs. So due to the deficiency or excess of electron, these both sodium and chlorine attain positive or negative charges. So basically charge is basically a property that arises due to deficiency or excess of electrons. Now if someone asks us that what is basically the mathematical definition of charge, then for that we define mathematically charge as a product of current multiplied by time. So if you define charge from this equation and derive its unit, that what is the unit of charge, then we confirm here that the SI unit of charge is basically ampere into second, because for current we put ampere and for time we put second. So basically ampere into second is equal to coulomb, and 1 coulomb is defined as the amount of, if the amount of current flowing through a given cross section of a wire is 1 ampere, and that 1 ampere current flows for the time 1 second, then we can say that that conductor possesses 1 coulomb charge. Now there are certain properties of charges. Basically there are two types of charges, positive charge, negative charge. Same charges, positive repel each other, or negative repel each other, and opposite charges, for example positive or negative attract each other. So we can say that positive repel and negative repel, or we can say that like charges repel each other and unlike charges attract each other. Similarly, when we say that a body is neutral, it means that their body possesses same number of electrons and same number of protons, due to which the net effect of the resultant effect of all of these charges becomes zero. So we say that basically a body as a whole is neutral. Now similarly, we already learned that basically static charge or charge at rest create only electric field, while charge in motion produce electric as well as magnetic field. So the static charge produce electric field around itself. Similarly, the charge is quantized as well as charge is conserved. But what is quantization, what is conservation, we discuss it later. Now first comes towards the quantization of charge. In Benjamin Franklin's day, charge was considered as a continuous, not a discrete entity. But later on, it is experimentally verified that when charge transferred from one body to another body, then it cannot transfer in continued form, but rather it transfer in packets form or energy bundle forms, and that energy packet means quanta or quantum of charge. So what is quantum of charge or what is quantization of charge? So quantization of charge means that charge transfer from one body to another body is always equal to the integral times of the smallest elementary charge particle charge. And the smallest elementary charge particle charge is basically equal to 1.6 cross 10 power minus 19 coulomb. That is basically the charge of electron or the charge of proton, depend upon the particular charge, whether that charge is proton or electron. For proton we take positive and for electron we take that charge as a negative. So when electrons transfer from one body to another body, then they always transferred in integral form, not in half integral form, because we cannot say that half electron is transferred or 3.5 electrons are transferred, but rather than we can say that basically 10 electrons are transferred, 20 electrons are transferred, and 30 electrons are transferred. So charge always transferred from one body to another body in integral times form. Or when we say that something has a charge, so from something have a charge or has a charge means how many times the charge it has, where n maybe 1 2 3 4 5 6, which is the principal quantum number. So charge always transferred in discrete form or in quantum form and cannot in continuous form. Now comes towards the conservation of charge. What is conservation of charge? Conservation of charge means that basically charge transfer from one body to another body always conserved, or we can say that charge is always conserved. And conservation means charge can neither be created nor destroyed, but charge can only be transferred from one body to another body. So as a whole, charge of the whole system must be conserved. And for example, when you rub a glass rod with a silk, then the glass rod becomes positive charge because it lost electron, and the silk on the other hand gain negative charge because silk cloth gain electron. So during the process of rubbing, basically there is no creation of charge on one body or another body, but basically there is transfer of charge occur from one body to another body, due to which they attain positive or negative charge. So charge basically transfer from one body to another body, not created at that time. Another example of that is annihilation of matter. When electron and positron annihilate each other, they produce a pair of two photons, and the energy of that two photons must be equal to the rest mass energy of these two charged particles. Similarly, in another decay process, when pion decay, it decay into two photons, which are basically gamma ray photons, and the energy of these gamma ray photons must be equal to the energy of this pion. Or if you study here, the charge on the right side must be equal to the charge on the left side. On the left side there is zero charge. On the right side we also see here that there is a zero charge. Similarly here the positive and negative charges cancel each other, and on the right side there is also charge 0 because gamma rays possesses zero charge. So I hope all of you learned some basic things about what is charge, what is quantization, and how charge is conserved. Our next topic is about the Coulomb's law. I hope you learn some basic things about the charge. Inshallah, Coulomb's law will be our next topic. Thank you.